what Sudarshan told to us. This is the inverse square law. For knowing Kepler's law, you should know what is inverse square law, then what is reduction to one body problem. Here a two body system with mass m1 and m2 can be simplified into particle problem using reduced mass. So this is the equation for two body problem using m1 and m2 divided by m1 plus m2. Okay, I will give you slide and then you will be understanding more. And next is conservation and planar motion. You know that torque is the rotational angle of force. So here the force is radial. So torque is 0. That's why it's conserved. And we know that what is planar motion. Here angular momentum L is constant. So that's why the planar it will be in a fixed plane. Okay. And energy conservation is the total energy is equal to potential energy plus kinetic energy. You know that also. So these are the basics. And I am just skipping this. This is what Sudarshan told in the figure last class. So everything is the thing which you will require for learning Kepler's theorem. So we can move to the verification of three laws of Kepler using the Kepler's problem. And Kepler's problem, actually just Kepler said about these things in this time. After that, Newton, after Galileo's birth, Newton born. That time he said about this Kepler and he did with this like of derivation. Okay, and so we can move to the derivation part. And so actually the Kepler's law was proposed by Johannes Kepler, and he has three laws, that is first law, second law and third law. So you may be knowing what is first law, what is second law, what is third law, and you want to know, otherwise you will learn now. So first law is what? In the first law it is said that it moves in rotating and elliptical orbit. We know that ellipse will have two focus and f1 and f2. At the one of the foci, the sun will be there. This is what? This is Earth. So Earth rotates around the sun in an elliptical way, and Earth rotates around sun in an elliptical way, and at the one of the foci, sun is situated. This is what the Kepler's first law saying about. So we are going to verify it using the different steps. And so this is what Kepler's law. This is the radius. And so knowing this, we want to know about the radius, means Deviga's homotopy. That is equation of orbits. That also we want to know. So we know that equation of orbit is took by Deviga, and it suggests that d square u by d theta square plus u is equal to minus m by L square u square f of 1 by u. This was the equation of orbit which we have just before. So this is equation of orbit. From this equation of orbit we are going to derive. And this is the equation by Deviga, and this is the equation by Sudarshan. And Sudarshan equation is f of r is equal to minus k by r square. So what we are going to do is we are going to mix Sudarshan and Deviga's orbit. So yeah. So we know that f of r is equal to minus k by r square. So r is equal to, we are going to substitute that r is equal to 1 by u. Guys, this is the equation of orbits and this is the equation of Sudarshan, that is what inverse square law. We are going to substitute r is equal to 1 by u in this equation. So it will become f of 1 by u is equal to minus k u square. So this is the second equation and this is first equation. So we got two equations now. Okay. So we are continuing the topic. We will be doing more and more. What we are going to do is, so So you know what is first law? This is first law. I am going to rub that also. And so we are going to use 2 in 1. So d square u by d theta square plus u is equal to minus m l square u square k u square. Okay. So we put 3 in 4. Sorry, 2 in 1. And then we got that as d square u by d theta square and plus q. We are taking this to this side, so it will be minus mk l square is equal to 0. This is the third equation. After that, we are taking this as x. So du by d theta is equal to dx by d theta. So from this we want to differentiate again and we will get it as d square by d theta square is equal to d square x by d theta square. So this is the
fifth equation.
This is the fourth equation. Okay. So up to now you get to 4 equations and you want to write the healthy. Okay. You can see and I will be posting you to. So these are the steps of derivation. Next we are going to use what this 4 in 5. We got the equation 4 and that is using in fifth equation. So we will get it as d square x by d theta square is equal to d square x by d square u by d theta square is equal to d square x by d theta square. We got fourth equation, we got fifth equation, equation 4, we get this like equation. This is the fifth equation. Then we are sixth equation is something d square x by d theta square plus x is equal to 0. This is the sixth equation. And after that, we know that the general solution for this. We know what is particular solution, what is general solution in the mathematics. The general solution for this is equal to x is equal to a cos theta minus theta dash. This is the equation for general equation. Then where a and theta are constants, here a is constant and theta is also constant. And we are going to compare 4 and this is 7th equation. So we are going to compare the 4th equation and the 7th equation. And we will be getting equation called 8th equation. That is u minus mk by l square is equal to a cos theta minus theta dash. This is the 8th equation and u is equal to mk by l square plus a cos theta minus theta dash. So u is equal to 1 by r. We know we substitute as the first step. So now we are writing it as 1 by r is equal to mk by l square plus a cos theta minus theta dash. Okay. And then we are going to multiply l square by mk on both sides. So we will get it as l square mk by r is equal to what? We are going to multiply l square by mk. So here it will be l square by mk. That is mk and mk cancel, l square cancel. There will be 1 and 1 plus. Here also we want to multiply it with l square by mk. So we will get it as l square by mk into A cos theta minus theta dash. Okay, so this is the nth equation of us, and the ninth equation is this one. So that we reach to 10 equation, and after that we are going to do is compare 10 with the general equation of conic section. And we know that the general equation of conic section, we know what is conic section, what is lattice rectum, what is eccentricity, like that we have in the conic section chapter of the plus 1 question. Okay, so L by R is equal to 1 plus E cos theta minus theta dash. Okay, so here this L is the lattice rectum. We know what is lattice rectum, and from our earlier classes what is lattice rectum. So that is L is equal to L square by MK. So this is the equation for lattice rectum. And next is E. This E is eccentricity. Eccentricity also we know from our conic section chapter. The equation for eccentricity here is E is equal to L square by MK. So actually Kepler's problem is a mathematical term related to this Kepler's law. They are using mathematical relation like mass, Lagrangian technique, etc. So after that we are going to differentiate and differentiate 9 on both sides. Differentiate the equation 9 on both sides. So we will be getting us minus 1 by r square r dot is equal to 0 minus a sin theta minus theta dash and theta minus theta dash. So after that we will be getting it as this is we will get it as L is equal to mr square theta dot is equal to theta dot so from this we will get theta dot is equal to L by mr square. Okay, theta dot is equal to L by mr square. So this is the 12th equation. And okay, so using 12 and 11, we are using this 12th equation and the 11th equation. We will get what? Another equation would 13th equation. So it is a very difficult to derive, and you got to really so what next is r dot is equal to a r square sin theta minus theta dash L by ml square. So r dot is equal to al by m sin theta minus theta dash. It's the 13th equation of us. And so from this, what we understood is 1 by r is equal to mr by l square plus a cos theta minus theta dash is the 9th equation we studied. So we are going to compare and invert this. Okay. So this is the 13th equation. Okay. And from that now total energy of a particle under central force. Central force grouped by negative. So from that topic to this topic, if you know that topic only, you can do this topic. If you know suppression topic only, you can do. If you know ready topic only, you can do. So without knowing anything, you can do. And so E is equal to half m r dot square plus b of r plus l square by 2m r square. So E is equal to half m r dot square minus k by r plus l square by 2m r square. This is the 14th equation of the derivation. So you understood in this. Okay. So we know that what v of r is the minus k by r. So using 9 and 13 in the equation 14, and we will be getting E is equal to half m al by m sin theta theta minus theta dash square minus k m L square by L square plus a cos theta minus theta dash plus L square by 2m by mk by L square plus a cos theta minus theta dash. So this is the equation for energy. E is equal to half m L by m sin theta minus theta dash square plus k into m by m square by L square plus a cos theta minus theta dash plus L square by 2m mk. Like this, the equation is that this is the equation we get for energy. So by simplifying this, there are numerous steps that I will be sharing notes. That time you may be understood how to simplify this equation. So after simplifying the equation, you may be getting that E, that eccentricity is equal to L square by ml. E is equal to L square by ml mk by L square plus root of 1 plus 2 L square E by mk square. So here E is equal to root of 1 plus 2L square E by mk square. So from this E is equal to 1 plus 2L E by mk square. E square means 1 is equal to 2L square E by mk. So we reach the E square minus 1 equation up to now. So from this we will be knowing about it what E is equal to 2L square by 2L square E square minus 1. This is the final equation of energy of first term. Okay. So from this we can understand what Reddy told in the previous session. That is, if E is greater than 1, E is less than 1, E is less than 1, then energy greater than then it will be a hyperbola, and E is equal to 1, E is equal to 0, then it will be a parabola, and E then it is less than E is equal to 0, it is ellipse, and then what E is equal to 0, E is equal to 2, E is equal to mc square by 2L square, it will be circle. So according to the value of E greater than 1 or plus than 1, and the energy eccentricity and energy's value will depend easily in a hyperbolical, parabolical, cylindrical, circular path. So here it is E square minus 1. So it will be in an elliptical path. So from this we understood that the first law is correct and sun is at the top. So next is the second law, that is law of equal areas or law of areas. So this is also proposed by Johannes Kepler, and the second law deals with the area. For that also there is a derivation. Next is Kepler's third law. For that also is a derivation. So we are going to verify these three laws. So next is Kepler's second law. Kepler's second law is about, we know that this is an elliptical path, and if it is there is an area like this means it is P1 and P2, and here we are drawing another area like P3 and P4. Here it is in P type, then P2 is equal to P2 plus D2, then here also D2 we are taking, and so this area and this area will be same according to the Johannes Kepler's second law. Okay. So from here we can take this one section, that is like this, that is like this, like this, okay. So So from that we will be doing like this is an arc, this is the radius r, this is r2. From that we will go into derive, then p1 like so many equations are there. I first can share you, otherwise you will get difficulty goal. So from that so we want to do so many derivation. This way you can see that from here we are starting our equation dA, we are going to then first we are finding dA, we are going to find, then we are finding dA by dt, we are going to find, and then we are going to find that dA by dt is equal to L by 2m, and angular momentum of a path will move on certain force we are going to find here. And after that we are going to find according to Kepler's law, we will be finding that v1 by v2 is equal to r1 by r2. And so v directly inversely proportional to 1 by r. And so linear velocity of a quantity is more close to sun. We know what is you know what is apogee or perigee or like that. If this is earth, this is earth, this is sun, and they are close, it is called what, perigee or perigee. Okay, that I will say. When it is nearby, it will be moving faster. When it is away, it will be moving slower, and nearby, it will be faster. This is also very useful, Kepler's second law. And next is the Kepler's third law. Kepler's third law, we are going to derive Kepler's third law. In the BSc, we want to know verify first law, second law, third law. Okay. And so next is law of third law, Kepler's third law. For the like Kepler only found 3 law, so that's we are going to end this in 2 or 3 minutes. We will derive it fastly. Kepler's third law means Kepler's third law. It is also known as law of periods, or it is also known as harmonic law. So this is the law where you ask for a 8th standard or question what is Kepler's law. The equation was E square directly proportional to A cube. That is the time period, square of time period is proportional to A cube. A is the what? Semi major axis. We know what is ellipse. So here it is the something like this. Everything is steady. So for an ellipse there will be what? A major axis will be there, a minor axis will be there. So this is 2a. And semi major axis means a. Then a. So a is the semi major axis. B is the semi minor axis. Okay. So we studied E square divided directly proportional to A cube. So for deriving this third law, we want to know what is Kepler's first law. We want to derive first law. So from that only we can derive third law. From that we found theta minus theta dash. Here there are 2 cases. That is theta minus theta dash for minimum and theta dash minus theta for maximum. So after telling that we can stop by this, and that because you may understand that simply. So here we are consisting of for this also you don't need to worry. This also have 1 page derivation, 2 page derivation. Like that we are going to find at class that so I am going to finalize that day. So there is an equation called, for that you first want to verify what is A, then what is B, then after that only you will mutual equal to that. So we want to know that B is equal to A L square by root MKA. So this is only you will be aware of this only from that which one first term. Okay. So T is equal to 2 pi m AB by L. This is the equation 10 that I will be sending you in the PDF. From that I want to find the equation 10. From equation 10 I am going to finalize. So B is equal to A by root A into L by MK. B is equal to root A L by MK. And so using 11 in 10, we will get T is equal to 2 pi ma by L root A L by root mx. So from this we will be finding T. From this we will be finding T square as 4 2 pi square, that is 4 pi by m square by mk a cube. So here we can find that these are constant, and so we can say that E square is directly proportional to a cube. So as we verified Kepler's third law, and actually this is only the indication part of Kepler's, and as per your degree syllabus, in this much only there is gravity related thing, electromagnetic big things. You may be now understood what is Kepler's problem. You just know Kepler's problem was found by Johannes Kepler, and then know about the central force theorem, like his inverse square law, the reduction of one body problem, two body problem, etc. Then what this angular momentum concepts, like that. Everything I said. If you have any doubt, you can refer YouTube. I will be sharing one video. So listen that video, please. 1 minute, I will not be playing, I will show. Goldstein. You are referring Goldstein. Here I will show you Goldstein. So this is a talk show related to Kepler's problem, and they are going to see. So this is Goldstein. So this is Kepler's problem video. You can